Geometry students, welcome to class this morning on Monday morning. Hope you guys had a good weekend. You should have in front of you your tests and quizzes and all of your homework that's been passed out. Jake, I want to remind you, I believe that your mom, I believe, has an envelope with some, excuse me guys, with some assignments in that envelope. Jake, make sure you give that to the supervising teacher or the office or someone and let me know who you gave it to. So I can definitely keep track of that in case they come up missing. So I'll be sure and get that turned in. But hope you guys had a good weekend. You should have papers passed back to you, tests. My voice is a little rough, so please just ignore that and do the best you can to put up with it. You should have your quizzes, your tests, and all of your homework passed out to you. All of your grades are updated. They'll always be updated every Monday morning. So, and if you're missing anything on that Sycamore account and you don't think it's right, you need to contact me, okay? So, okay, very good. Here come the announcements for today, so please really pay attention. It's not what I wanted to do. That is a email that I sent Joey telling him what to do for class. I'm not sure why it just popped up. That's kind of funny. It was telling him what video to have you guys watch. Okay, let's try this again. There we go. Okay, quiz on Friday. All right, there will be a quiz this Friday. I will talk more about that on Thursday and give you the information. Please make sure you're studying all week long. Make sure you're listening all week long. Make sure you're doing your homework, asking questions, calling me, emailing me, watching the homework help videos, and not getting behind. Number 2, you have no homework from over the weekend. I said to collect. I really should have said to turn in. So unless you're turning in incompletes, other than that, you have nothing to turn in from over the weekend. Jake, I emailed Mrs. Ware about your test. I will be in contact when I get information about that. I'm not sure where it is. I mean, I'm sure she has it. I just have not seen her. On Sunday, before my church started, I went over to Brian and looked in my box, and it was not there. And I checked her box, and it was not there. So if you get a chance today, Jake, do me a favor, talk to her and tell her that I asked you to make sure she puts that in my box. And so please, and I've also emailed her, so I'll try to get to the bottom of this. Okay, here we go. If you would start off by getting out let me give you a little heads up as to what we're going to do today, guys. First of all, if you do not get through this entire video today, I don't think this is right. I had some more announcements I could have sworn. I wonder if that page is buried somewhere. Okay, well anyways, if you guys do not get to the entire video today, you are to finish this tonight at your house. Let me say that again. If you do not get to this whole video in class today, you are to finish it tonight at your house. You have no homework tonight. I'm not giving you any homework. I'm going to teach for a very long time, and I'm going to I want you to come in tomorrow and practice the homework with me, using a video. So if you do not finish this, you need to finish it tonight. There is no homework, okay? All right, first of all, get out your quizzes, would you please? I want everyone to get out their quizzes, and I want us to find our mistakes, okay? So everyone get out your quizzes, and let's go over the ones that you missed. Now remember, not all of you missed these, but at least one person missed each of these problems. A segment bisector is a segment rare line that intersects a segment at its midpoint. Supplementary angles, two angles whose sum is 180. Adjacent angles, two angles that share a common vertex and a common side. By the way, you are more than welcome to switch those two. I don't care what order you had those. A theorem is a true statement that follows from other true statements. Theorem 2:1, if two angles are complementary to the same angle, then they are congruent. If two angles are supplementary to the same angle, then they are congruent. By the way, if you swap these two words, I didn't care. That was totally fine. Okay, some of you missed B, so please pay attention. Notice B is the midpoint of AC, so B is right in the middle. If B is right in the middle, then that means these two expressions have to be equal. Each length has to be the same. So 2x plus 5 equals 3x minus 10. Bring the 3x over and make it a negative 3x. A negative 3x and 2x is negative x. Bring the 5 over and make it a negative 5. A negative 5 and a negative 10 is a negative 15. And then there's a negative 1 right here, even though you can't see it. Divide both sides by a negative 1, and negative 15 divided by negative 1 is 15. Question number 13, find the midpoint that falls between these 2 points. Well, remember, we take x plus x, that's 3 plus 7, and divide it by 2. Here's your x, here's your y, here's your x, here's your y. And then you add your 2 y's, 8 plus 6 divided by 2. And so 3 plus 7 is 10, divided by 2 is 5. 8 plus 6 is 14, divided by 2 is 7. So there's the midpoint right there. Ray BT is an angle bisector. That means this line right here in blue cuts the red angle right in half. Cuts it right in half, okay? So that means this angle right here is congruent to this angle right here. These two little angles are congruent. All right, let's continue on here and see what it says. If ABD is 40, so this little angle here is 40 degrees, ABD, what is the measure of ABC, the whole angle? Well, if this little angle is 40, that means this little angle is 40, so the whole angle together has to be 80, 40 plus 40. Okay, number 15, ray BD is an angle bisector. So again, this ray is a bisector. That red ray is a bisector of the big blue angle. All right. If angle ABC is 100, ABC, so this whole angle is 100, students. What is the measure of ABD, this little angle? Well, think about it, guys. If 40 plus 40 is 80, the whole angle is 80. Divide 80 in 2, you get 40 and 40. Well, if this whole angle is 100, divide 100 in 2, and you're going to get 50 and 50. So the measure of angle ABD, this angle right here, is 50 degrees. Okay, moving on to number 17. Angles A and B are supplementary. If angle A is 43, what is the measure of angle B? Well, if they're supplementary, that means if you add A and B together, you get 180. So if one angle is 43, I'm going to take 180 and subtract 43. And I will get 137 degrees. So angle B has to be 137. And that makes sense. If you take 137 and 43 and add them together, you will get 180. Okay, now we're moving on to the test, okay? So go ahead and pause the video if you need to, get out your test, and let's go over your test now. Okay, midpoint, the point on this segment that divides it into two congruent parts. You should have your tests out. If you didn't miss number one, then just kind of relax and be respectful to your classmates. If you missed number one, find where your mistake was. Look at each problem. And by the way, Azu had the only perfect test. So Azu, congratulations. She had a 100 on her test, made no mistakes on the entire test. So Azu, just find something to do, work on another subject, or just kind of listen along if you want to. Okay, if you missed number 6, pay attention. Adjacent angles would be two angles that share a common vertex and a common side. Postulate 7, if two angles form a linear pair, then they are supplementary. Law of detachment, if the hypothesis of a conditional statement occurs, then the conclusion will also occur. Okay? Find the measure of angle ABD. This is number 17. So if you missed number 17, please pay attention. Find the measure of angle ABD. That's the big angle. Segment BD is an angle bisector. So this ray right here cuts the big angle right in half. So if this angle is 84, then this angle has to be 84. So the measure of the whole angle has to be 168. I added those two angles together. Okay, if you missed number 23, please follow along. Rewrite in the space provided below the following statement as a conditional. Now some of you, I think one of you put, if the doctor stays away, then you ate an apple. And that's not true. The doctor might stay away because he doesn't like you. The doctor might stay away because he's sick. The statement says, an apple keeps the doctor away. an apple keeps the doctor away. So you should have written, if you eat an apple per day, then the doctor will stay away, or then it keeps the doctor away, whatever. But the if part has to be if you ate an apple, or if someone eats an apple, then the doctor will be kept away, whatever, something to that effect. But that is the if part. All right, 24. Use the law of detachment to reach a conclusion. All right, now here we go, a law of detachment. If E is between D and F, then we have this. E is between D and F, so if look guys, look, if E is between D and F, then we'll have this. And then it says E is between D and F. So you would write then DF equals DE plus EF. There you go. That's all you had to write. I mean, it makes total sense. If this, then this. Then it's saying, yes, the hypothesis did occur. E is between D and F. Then the conclusion will occur. DF equals DE plus EF. Okay? I'm not saying it's easy. I know it's not, and I'm just going to get tougher as the year goes on. But hopefully, as we go over these problems, they will make sense. Okay, let's go ahead and pause the video if you need to. Grab your notebooks, grab your pencils, grab your calculators, grab your books, and let's take some notes for a good long time. Today's math will be difficult, so I need you to really, really, really pay attention, really be ready to think outside the box, and call me or email me if you have questions, but you're really going to have to pay attention. This is not going to be easy. All right, let me get a drink of water here. And let's get started. In your notes, go ahead and write down properties of equality and congruence. Properties of equality and congruence, lesson 2.6. And if you'd like to write the date down, which I encourage you to do, today's the 16th. Properties of equality, that means equal signs, and congruence, congruent signs, lesson 2.6, and today's the 16th. Now, again, I go fast on purpose. Pause the video when you need to. Understand that the notes will not be the easiest to understand, and there will be a lot of notes. However, I'm not going to give you homework. I've mentioned this before. I'm just reading it again. I want us to work through those together tomorrow in class. If you don't finish this video, you are responsible to finish it tonight at home. So I'm just repeating what I said earlier. Okay. If you want to turn your books, feel free to do that, okay? Page 88 at the bottom. This is exactly what you'll see. Page 88 at the bottom. And I want to start off by looking. In fact, if you'll turn there, go ahead and turn there in your books. I think it'd be a wise thing to do. You'll see the heading. I wish I hadn't cut it off. It says properties of equality. Sorry for yawning. I apologize. Properties of equality and congruence. Properties of equality and congruence. Okay? Now listen carefully to these three properties. They're going to seem a little dumb and probably a little, well, duh, that makes sense, but you still have to know the names. I didn't write geometry. I'm just telling you now what you need to know. So please follow along in your book and look up here at the screen and really pay attention. The reflexive property is of equality. That means you have an equal sign. Is something like this. AB equals AB. Measure of angle A equals measure of angle A. 5 equals 5 would be an example of reflexive. Y equals Y. That's an example of reflexive. Let's see. Well, I'm drawing a blank, but anything that has the exact same thing on one side and the exact same thing on the other with an equal sign between them, we call that the reflexive property of equality. Now, if you don't have equal signs, instead you have congruent signs like we do over here, please look right here, then we call this the congruence, the reflexive property of congruence. The reflexive property of congruence. And it's the exact same thing, only instead of having an equal sign right here, you have a congruent sign. So not that big of a deal. AB is congruent to AB. Of course it is. Angle A is congruent to angle A. Of course. So anytime you have the same thing on both sides with an equal sign or a congruent sign, we call it the reflexive property of equality or the reflexive property of congruence. Now, the symmetric property, please pay attention. If AB equals CD, then CD equals AB. Once again, another duh moment, but still, you need to know what that property is called. It's called the symmetric property. If the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. See how they swap places? Okay, that's called the symmetric property of equality because we had equal signs. We call this property the symmetric property of congruence when we have congruent symbols. Look over here. If AB is congruent to CD, then CD is congruent to AB. If angle A is congruent to angle B, then angle B is congruent to angle A. This property is called the symmetric property, and you need to understand that. Now let's take a look at the transitive property. Look at this. Be careful. Look. This is like the law of syllogism. If AB equals CD and CD equals EF, then AB has to equal EF. Think about it. AB equals CD. CD equals EF. Well, then AB definitely has to equal EF. Piece of cake. Look, if the measure of angle A equals the measure of angle B, they're the same. And then the measure of angle B equals the measure of angle C, they're the same. Then the measure of angle A has to equal the measure of angle C. So whenever you have a situation like that, it's called the transitive property. Now, if you're dealing with equal signs, then we call it the transitive property of equality. If you're dealing with congruent signs, then we call it the transitive property of congruence. Either way, it's the exact same thing. Look over here. AB is congruent to CD. CD is congruent to EF. Thus, AB is congruent to EF. Exact same thing. So that's called the transitive property. All right. Now, in your notes, my voice is pretty rough, guys. Let me get her a drink of water here real quick. I just hope I'm not getting sick. Okay, moving on. Okay, you're welcome to just write down page 89, example number 1, if you want to, and let's try to match these examples with the correct property. Okay, so you can turn in your books to 89, or you can just look up here, whatever you want to do. In your notes, I would write page 89, example number 1, so you know where this problem came from. Now, if GH is congruent to JK, then JK is congruent to GH. Well, which one of these properties, reflexive, symmetric, or transitive, had the examples where things were swapped, turned around? Wasn't it symmetric? AB is equal to CD, then CD is equal to AB. So we know we're dealing with symmetric. Now let's go back to the problem. Are we dealing with equal signs or congruent signs? Well, we're dealing with congruent signs. So we know it's symmetric and we know it's congruence. So number 1 would be the symmetric property of what? Congruence, sure. How about DE equals DE? Wasn't that reflexive? AB equals AB, angle A equals angle A. Sure it was. And are we dealing with equality or congruence? Well, it looks like we have an equal sign, so I'm going to say we have the reflexive. Letter B is an example of the reflexive property of equality. And now number C. P is congruent to Q. Q is congruent to R. So P is congruent to R. Well, look, guys, that's the last one we studied, the transitive property. So we know it's transitive. So letter C is an example of the transitive property. Now hold it. Is it transitive property of equality or transitive property of congruence? Well, I have congruent symbols, not equality, not equal signs, so it's the transitive property of congruence. Okay? I hope that helped. All right? I'd like you to quickly copy this in your notes. I'm going to move on. If you have to pause the video, that's fine. In the diagram, N is the midpoint of MP, and P is the midpoint of NZ. Now I wonder why that says Z. Did I copy that wrong? This should be a Q right here, and I apologize. Would you please fix that in your notes? I'm going to fix it real quick because I like my notes to be correct. Okay, there we go. All right. N is the midpoint of MP, and P is the midpoint of NQ. Show that MN is congruent to PQ. Now, let's really just, this is not going to be easy, okay? This is doing a proof, is what we're doing here. It's going to be pretty tough, but I want you to sit back, take some really good notes, and just kind of watch and see if this makes sense, okay? I've got to kind of lay a plan of attack here, okay? And I know that N is the midpoint of this segment here. So I know that this segment's congruent to this segment. But then hold it, look guys, I know P is the midpoint of NQ, which means this segment's also congruent to this segment. Let me go over that again. N's the midpoint of MP, all right? So I know this segment here is congruent to this segment here. And then I know P is the midpoint of this segment here. And so because I know that, this segment here is congruent to this segment here. So it looks like all three are congruent. So I'm going to write some statements down, and I'm going to kind of prove them off to the side. I'm going to start off by saying MN is congruent to NP. Okay, I can write that, and the reason would be, my reason would be, write this down. We're doing a proof. We're actually doing your first geometric proof we've ever done, that you've ever done, so please write this down. That's the definition of midpoint. Look what you're given. N is the midpoint of MP. So if N is the midpoint of MP, then I know that MN is congruent to NP, definition of midpoint. Now, let's take a look at this. I can also state that NP is congruent to PQ, because it says right here P is the midpoint of NQ. So P is right in the middle of this segment here. So I can definitely state NP is congruent to PQ, and the reason again would be definition of midpoint. Think about it. I know P is the midpoint, so based on the definition of the midpoint, I can state that NP is congruent to PQ. Now look at this. Look, transitive, transitive. Say it with me out loud. Look, MN is congruent to NP. NP is congruent to PQ. Thus I can state MN is congruent to PQ, and my reason would be transitive property of congruence. And isn't that what I was supposed to do? Look up here. What was I supposed to do? Show that MN equals PQ. MN equals, or is congruent to, that's fine, PQ. There we go, we did it. Pretty cool. And I'm not asking you to do it on your own yet. I'm not giving you homework tonight. I'm going to tomorrow in class work through the homework with you, but I just want you to open your mind up to this and think about it and try to understand it. All right? Okay, now in your books you can turn to page 90 if you would like to. I would encourage you to do that and kind of follow along as I go over some of these examples. And to give you some closure, we're just about done. It's not too bad. I mean, a couple more things here, a couple more examples, and we're done. So hang in there, finish really well. If you do finish the video early, then do not goof off and cause problems. Please find something to do. And when you come in tomorrow, we will get right into your homework right away. Okay? All right, here we go. Top of page 90, all right? Properties of equality. Notice I start off with x minus 3 equals 7. You can see that in your book if you'll look. And then notice I add the same number to both sides. I add 3 to this side, and I add 3 to this side. Well, if I add the same number to both sides, we call that the addition property of equality because I added something to both sides. Look at this. Y plus 5 equals 11. So I subtract 5 from this side, and I subtract 5 from this side. We call that the subtraction property of equality because I subtracted the same number from both sides. Look at this. I multiplied 1/4 z by 4 and I multiplied 6 by 4. So I multiplied both sides by 4. When you multiply both sides by the same number in an equation, we call that the multiplication property of equality. Look at this. 8x equals 16. We divide one side by 8, divide the other side by 8. We call this the division property of equality. And then this is not the best example. Yeah, I guess it is. 2x plus 4. I would have rather they wrote this below it. I'm going to cross this off. I really don't think that's the best thing to do. Now, please don't draw in your books, but I have x equals 7. I have 2x plus 4. And then where the x is, I substitute a 7. We call that the substitution property of equality. If x equals 7, then I'm more than welcome to substitute 7 in for x. Or I could substitute x in for 7. We call that the substitution property of equality. Okay, let me again grab a quick drink of water. And let's look at a couple examples and we'll be finished for the class period, okay? All right, write this in your notes, please. Angles 1 and 2 are both supplementary to angle 3. Show that 1 is congruent to 2. Angles 1 and 2 are both supplementary to 3. Show that 1 is congruent to 2. Now here's what I'm going to do. I'm going to get a picture of this. So I'd encourage you to do the same thing. Copy this problem down. And then we're going to say angle 1. Let's just do something. Well, let's see. We'll put angle 1 here. Put angle 3 in the middle, please. And then put angle 2 over here. Okay? Angle 1 is supplementary to angle 3. And angle 2 is supplementary to angle 3. Angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 3. Show that this angle here is congruent to this angle here. Writing down step by steps like we did 2 problems ago right here. Kind of like a proof situation where we make a statement and then tell why. Well, the first thing I'm going to write is this. This makes sense. I'm going to write the measure of angle 1 plus the measure of angle 3 equals 180. Now, what's the reason that I can state that? Well, watch. You need to get used to this. Definition of supplementary angles. I mean, it says right here, 1 is supplementary to 3. So I know that 1 and 3 have to add up to 180. Well, I can also state that the measure of angle 2 plus the measure of angle 3 equals 180. And once again, the reason is definition of supplementary angles, because it says right up here, it says angle 1 is supplementary to 3 and angle 2 is supplementary to angle 3. Now, think about this for just a second. The measure of 1 plus 3 equals 180, right? And look at this. Sorry, guys. Look at this. The measure of angle 2 and 3 equals 180. Now, watch this. Watch. What does this equal? It equals 180. Do you see that? Angle 2 plus angle 3 equals 180. So then if it equals 180, can I not substitute it in for 180 up here? Sure I can. Look, if I said 2 equals x, and there was an x up here, I could substitute 2 in for x, definitely. So, if the measure of angle 2 plus the measure of angle 3 equals, it's the same as equals 180, then I can substitute this in for 180. So now I have the measure of angle 1 plus the measure of angle 3 right here, and then equals, like I have right here. Then instead of putting 180, I'm going to put equals the measure of angle 2 plus the measure of angle 3. Now, how am I allowed to do that? What's my reason? Well, we just learned it a little bit ago. Substitution. Now, sorry about that. I do know how to spell. Actually, I'm doing this, as funny as you are laughing at me, I'm doing this at about 12:40 in the morning, and so I'm a little tired, but I do know how to spell. I'm just really tired, so oh well. Okay, so substitution. Now, look, I picked this up right here, and I put it in for 180 because it equals 180. All right. Oh, look how cool this is, guys. You not see what to do now? What can I subtract from both sides? I can subtract the measure of angle 3 from one side as long as I do it to the other side. And if I subtract them, they cancel out. And look what I'm left over with. The measure of angle 1 equals the measure of angle 2. Okay? And of course, my reason would be the subtraction. And you can definitely, you don't have to write out subtraction. Subtraction's good enough. If you want to write out subtraction, property of equality, that's fine. But in my classes, you're welcome to put just subtraction. I know what you did. But hold it, we're not quite done. I have the measure of angle 1 equals the measure of angle 2. They want me to show that 1's congruent to 2. So my next step is I'm going to simply write angle 1 is congruent to angle 2. And how can I state that? Well, guys, it would be the definition of congruent angles. Think about it. Definition of congruent angles. Look, if two angles are equal, then they're definitely congruent based on the definition of congruent angles, because the definition of congruent angles is two angles are congruent if they have the same measure. So I stated right here, the measure of angle 1 equals the measure of angle 2. Now I can state they're congruent by definition of congruent angles. If you're a little lost, you're very normal. This stuff is very difficult, and that's why I'm going to teach today. No homework tonight. I don't want you to go home and get all flustered and frustrated and confused. I want you to come in class tomorrow, and we're going to work on some homework together. All right, one more problem, and we are done. Okay, so here we go. All right, write this down, please. In the diagram, M is the midpoint of AB. So M is the midpoint. Show that AB equals 2 times AM. All right? Again, in the diagram, M is the midpoint. Show that AB, the whole segment, equals 2 times AM, which does make sense, okay? All right. The first thing I can definitely state is that MB, or AM if you will, AM equals MB. And that would be definition of midpoint. Look at your given, guys. Look what they gave you up above. They said M is the midpoint. So as soon as we know that M is the midpoint, we can state that AM equals MB, definition of midpoint. All right? Now, watch carefully what we do next. Remember, when I have 3 points in a row like this, I can state that segment AM plus segment MB equals the whole segment AB. And we call that segment addition. Segment addition, okay? So, AM, this segment, plus this segment equals the entire segment, and that does make sense. So, AM plus MB equals AB. Now, would you please look at this? What does AM equal? AM equals MB. AM equals MB, and here's MB. Can I not substitute AM in for MB? Sure I can. AM equals MB, so where MB is, I can write AM plus AM equals AB, and we would call that substitution. Substitution. And then lastly, we have AM plus AM I would just simply write, the book gives a different reason, but I would have no problem with you writing 2 times AM, and I would just say simplifying. I mean, that's all you're doing. You're just simplifying. I don't have a problem with that at all. You're just simplifying. AM plus AM is the same thing as 2 times AM. And look, you did it. That was your goal. Show that AB equals 2 times AM. AB equals 2 times AM. We did it. This is going to take a lot of practice, students, and a lot of, unfortunately, sweat and tears and hard work. But you can do this, but you're just going to have to really work hard. Come in here tomorrow. Please have your books ready, your homework ready, everything ready. We're going to work on homework tomorrow for the whole class period. And if you didn't get to finish this video, be sure, of course, to finish it like you're supposed to tonight. Have a great rest of the day. We'll work on homework tomorrow. We'll have a quiz this Friday.